In the previous video, we looked at using dialog widgets to copy files to your network. We'll use TCP/IP to communicate via networks. In this video, we'll create a TCP server to simulate connecting to a server in our local area network or on the internet. We'll then turn our queues module into a TCP client. Let's dive in. This video shows you how to use sockets to communicate via TCP/IP. In order to achieve this, we need both an IP address and a port number. In order to keep things simple and independent of the ever-changing internet IP addresses, we will create our own local TCP/IP server and, as a client, learn how to connect to it and read data from a TCP/IP connection. We will integrate this networking capability into our GUI by using the queues we created in previous videos. Here, we will create a new Python module, and we'll call it tcp_server.py. It will be the TCP server. How to do it? One way to implement a TCP server in Python is to inherit from the socket server module. We subclass base request handler and then override the inherited handle method. In very few lines of Python code, we can implement a TCP server module. Here's the code for it. We are passing in our request handler class into a TCP server initializer. We can also show empty single quotes for passing in localhost as a shortcut, which is our own PC. This is the IP address of 127.0.0.1. The second item in the tuple is the port number. We could choose any port number that is not in use on our local PC. We just have to make sure that we are using the same port on the client side of the TCP connection. Otherwise, we would not be able to connect to the server. Of course, we have to start the server first, before clients can connect to it. Let's modify our queues.py module to become the TCP client. This is all the code we need to talk to the TCP server. In this example, we are simply sending some bytes to the server, and the server sends them back, prepending some strings before returning the response. This shows the principle of how TCP communications via networks work. Once we know how to connect to a remote server via TCP/IP, we will use whatever commands are designed by the protocol of the program we are interested in communicating with. The first step is to connect before we could send commands to specific applications residing on a server. In the write to scroll function, we will use the same loop as before, but now we will send the messages to the TCP server. The server modifies the received message and then sends it back to us. Next, we place it into the GUI member queue, which, as in previous videos, runs in its own thread. In Python 3, we have to send strings over sockets in binary format. Adding the integer index now becomes a little bit convoluted, as we have to cast it to a string, encode it, and then cast the encoded string into bytes. Note the B before the string and then, well, all the rest of the required casting. We are starting the TCP server in its own thread in the initializer of the OOP class. Like this. We also need to import TCP_server as well. Clicking the Click Me button on tab 1 now creates this output in our scroll text widget, as well as on the console, and the response, due to using threads, is very fast. That brings us to the end of this video. We are running both the queue and the server in their own background thread, which keeps our GUI very responsive. Awesome! In the next video, we'll learn how to read data from websites.